Look up at the night sky. What do you see? Thousands of twinkling stars. Each star is a giant ball of hot gas. Stars are scattered throughout the vast universe. They are the building blocks of galaxies, and they play a vital role in our cosmos. Stars might seem eternal, but they have a life cycle just like us. They are born, they shine brightly, and eventually they die. But their deaths often pave the way for new beginnings. Their story is one of incredible transformations, from dust to brilliant light and back again. Let's journey through the life of a star. From its birth in a cloud of gas and dust to its dramatic demise, leaving behind a legacy that enriches the universe. Prepare to be amazed by the cosmic dance of creation and destruction, for the story of a star is a story of the universe itself. Stars are born in giant clouds of gas and dust called nebulae. These nebulae are like cosmic nurseries, filled with the raw materials needed to create stars. Gravity plays a crucial role in this stellar birth. Imagine the gas and dust particles as tiny dancers swirling in a vast cosmic ballet. Gravity acts as an invisible force, pulling these dancers closer. As the particles clump together, the cloud's center gets denser and hotter. This central region, called a protostar, continues to heat up under the relentless pull of gravity. When the protostar's core reaches a scorching 10 million degrees Celsius, a magical transformation occurs. Hydrogen atoms, the simplest and most abundant element in the universe, fuse together, creating helium and releasing an enormous amount of energy. This nuclear fusion marks the birth of a star. Once nuclear fusion ignites in its core, a star enters a long and stable phase of its life called the main sequence. Our own sun is a main sequence star, and it has been steadily shining for about 4.5 billion years. During this phase, stars are in a delicate balance. The outward pressure from nuclear fusion in the core counteracts the inward pull of gravity. This balance allows stars to maintain a constant size and luminosity for millions or even billions of years. Think of it like a cosmic tug-of-war, with gravity pulling inwards and fusion pushing outwards, keeping the star in perfect equilibrium. The color of a main sequence star depends on its mass. Massive stars are hotter and bluer, like brilliant sapphires in the cosmos. Less massive stars, like our sun, are cooler and appear yellow or orange. These stars are the cosmic engines that illuminate the universe, providing light and warmth to their surrounding planets. Section 4. When stars grow old. After millions or billions of years, a star starts to run low on hydrogen fuel in its core. This marks the beginning of the star's final chapter. As the core contracts and heats up, the star's outer layers expand dramatically, transforming it into a red giant. Imagine a balloon inflating as the air inside heats up. That's similar to what happens to a star in its red giant phase. The outer layers expand outward, becoming cooler and glowing with a reddish hue. Some red giants, like Betelgeuse in the constellation Orion, become so large that if they were placed in our solar system, they would engulf the inner planets, including Earth. During this phase, the star's core becomes a cosmic alchemy lab. Heavier elements like carbon, oxygen, and even iron are forged through nuclear fusion. These elements, created in the heart of dying stars, will eventually become the building blocks for new stars, planets, and even life itself. Section 5. Stellar fireworks. The way a star dies depends on its mass. Smaller stars like our sun will eventually shed their outer layers into space, forming beautiful glowing clouds of gas and dust called planetary nebulae. The remaining core, a white dwarf, will slowly cool down over billions of years. Massive stars, however, meet a much more dramatic end. They explode violently as supernovae, briefly outshining entire galaxies. These cosmic explosions release an unimaginable amount of energy and scatter the heavy elements forged in the star's core throughout space. The remnants of a supernova can form incredibly dense objects called neutron stars, where matter is packed together as tightly as in an atomic nucleus. Some massive stars leave behind black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape. Section 6. We are stardust. Although stars eventually die, their story doesn't end there. The material ejected into space during planetary nebulae and supernova explosions enriches the interstellar medium, the space between stars. This material contains the building blocks for new generations of stars and planetary systems. The iron in our blood, the calcium in our bones, the oxygen we breathe, all these elements and more were created in the hearts of stars that lived and died long ago. We are literally made of stardust, connected to the cosmos in a profound and intimate way. Each atom in our bodies has a cosmic history, a story that stretches back billions of years to the fiery crucibles of long-gone stars. The next time you look up at the stars, remember that you are not just observing them, you are connected to them, part of their grand cosmic cycle. Section 7. The enduring legacy of stars. Stars are more than just points of light in the night sky, they are the engines of cosmic evolution. They illuminate the universe, create the elements necessary for life, and leave behind remnants that shape the cosmos for billions of years. Understanding the life cycle of stars allows us to grasp our place in the vastness of space and time. So, next time you gaze up at the stars, remember the incredible journey they have taken, from dust to light and back again. Let their story inspire you to learn more about the universe and our place within it. For in the words of Carl Sagan, we are a way for the cosmos to know itself.